tensions. We have a node here, and this object, which has a weight of 100 newtons, is held by this rope going to this node, and we have two more strings leaving, creating angles theta and phi with a horizontal. Theta and phi. These are Greek letters. Let's say that these angles are 30 and 60. So what we do see is what are the forces on the node. So the node is the point mass, and it has three forces. It has the tension on rope 1, tension 1. It has tension 2, and it has the third tension, which actually is equal to the weight of the box that is hanged. Now, what about the angles? You can see that the angle here is with a horizontal. That means that the angle that we know between the tension will be the same between the tension and the horizontal. Just like here, just because we know the angle between the rope and the horizontal, we know that this is equal to the angle of the tension between the tension and the horizontal. And how can we see that? Well, think about having the x-axis here. This is parallel to that, so this angle should equal to this angle. And this is what we have here. So this is how it works. Right now we have to resolve two forces, tension 1, tension 2. So what I'm going to do, I will make one more free body diagram where only the force due to gravity will stay as it is, and the other two will be resolved. I will have tension 1x, tension 1y, tension 2x, tension 2y. That's the graphical part of the splitting the two tensions. Now, what about math? So T1x will equal T1 cosine the angle phi, which is 60. And the cosine of 60 is half, so this will be, the cosine of 60 is half, yes, half T1. T1y will be T1 sine of the angle phi, which means 0.8, 60 T1. Tension 2x will be T2 cosine of theta. Cosine of theta, it's 30, so this will be 0.8066 T2. And of course T2y will be T2 sine theta equals half T2. So we do the free body diagram. When there are forces not on the axis, we resolve them, and now we move to the next step. The next step is finding which option we have. So the node is not moving, so we have the first option, meaning that the sum of forces on both the x and the y-axis should be 0. So the sum of forces on the x-axis, I forgot annex here. Positive, negative, positive, positive, negative. So on the x-axis, I have that T1x minus T2x equals 0. That means that the two horizontal components should be equal to cancel each other. On the y-axis, we have T1y plus T2y minus Fg equals 0, meaning that T1y plus T2y equals the force due to gravity, which is 100. Can I simplify this too? Yes, I can. I know T1x, T1y, and so forth. So what do I have? I have that half T1 equals 0.86 T2. And here I have that 0.86 T1 plus half T2 equals 100. So I have two equations with two unknowns. I will definitely be able to find them. Now, I don't have enough space, so I think I should erase some of it here. So solving the one of them, let's say solving this, I find that T1 will be, I will need to divide by half, so I will find that T1 will be 1 over 73, pretty much T2. And going here, I would say, okay, so 0.861 T1, and how much is T1? Is 1.73 T2 plus half T2. Equals 100. So by multiplying these two, I will find that this is pretty much like 1.5, let's say T2 plus half T2 equals 100, meaning that 2 T2 will be 100 and T2 will be 50 newtons. Going back here, I say, all right, so that means that T1 is 1.73 T2, which is like maybe 87 something newtons. 1.73 times 50 equals 86.5, 87 newtons. So I found both tensions. That's it.